Good evening. So today or tonight I will be showcasing my game. The game that I chose to implement is Frogger, an old school arcade game where the objective is for the player to start on one side of the road and traverse through traffic to reach the other side, and they play as a frog, and the obstacles or enemies are the cars moving at various speeds across the roads in different directions, either to the left or right. So first I will be going through my Verilog design that I implemented. Most of the changes I made were towards the skeleton, which is the highest level Verilog file. So we see off the bat that I have up key state, down key state, right key state, and left key state. These four variables are used to track the player's input in the form of the D2 board keys or buttons, push buttons. And so those are very critical, and those are assigned to pins. I chose to reroute the reset pin assignment from key 0 and chose to reroute that pin to the right key state. And so instead of resetting the board when you press that push button, it moves the player right. Alright, moving on. I also have these variables here. Now, the four variables, frog x, y, frog x, frog y, car1x, car1y, car2x, car2y, car3x, car3y, are the variables that are output on values outputted on the hex displays to track the player and game progress. And those are actually routed all the way down to the lowest level Verilog file as well, which is the register file. So these variables are input into my processor right here. If we go to my processor, go all the way up here, we see them here, and then those have to be also routed into my register file upon each call. And in my register file, Verilog file, is where I make my assignments for those variables. And we see that those variables are assigned to respective registers, and so this is a way to always maintain values, constant values for the registers. For the variables, they're always up to date because they're always maintaining outputted file data in their respective registers, as well as also the up key, down key have their own registers as well, which are 10 through 13. And the write enable is always set to 1. And so when the key is pressed and this is 1, the 1 is written there. So that's always set to 1 and high. So that's pretty much it for those are the variables that I routed down to the lowest level. I also routed a variable called miscellaneous and lives. Lives is used to track the player's lives, obviously. Miscellaneous is a variable that I needed to route up to the top level design in order to update the game state. If we go all the way up to the skeleton again, we see that I also kept the LCD variables, and those were necessary in order to output on the LCD display, which I use at the end of a game where either the player loses or they win. So that's also a good another resource that I utilize. And also, last but not least, the D2 board, I also use the LED assignments and to display the lives, and I display the number of lives in the binary form. Alright, and so that's it for my Verilog design. Moving on to my assembly code, it's pretty straightforward. We have all of my variable assignments. By the way, the Frogger implementation that I decided to go with utilizes a 10 by 10 grid. So the boundaries are 10 by 10. The player can't go greater than 10 or less than 0 in either the X or Y position. Once the player reaches the 10th position in the Y direction, they have essentially won the game. And we see here that these assignments for my cars all match, are all loaded into their respective registers as assigned in the register file. And we also see velocity, which is used to control the speed at which the cars move across the the grid. And when the car reaches one end, say 10 or over 10 or lower than 0, they get rerouted to the other side based on their direction. So if it's going left, it's going to reach -1 and be rerouted back to the ninth position on the grid and continue. And then we have our game loop here, which always checks for the player input with these jumps here, and then it checks the player's boundary, makes sure the player itself doesn't go out of the bounds of the grid unless they win. They check resets the car's position for the cases that I just mentioned. The car timer is because instead of if I were to write every cycle, we wouldn't be able to see the actual output, the updating of the game state, because it would move so fast. So in order to remedy that, I put a timer for when it updates and how often it does. So with that being said, I will now demonstrate my game functionality. So right off the bat, we notice a bunch of numbers being updated. To the far left side is the player's X and Y position. You notice that some of the LED segments are off, and that's because of a problem with the actual hardware. The actual values are correct. As we also see here, that was a 2, that's a 0, and that's a 9, that's an 8, but the lowest LED is not, remains off, which is, the software is right, but that is a small error. Now, as I said, we use these keys. This leftmost key and the rightmost key are for left and right. This is the up key, and this is the down key. And so we see that there's some numbers moving faster than others. That's a fast car, obviously. And we see that their Y positions remain the same. They don't change. And that's because these cars don't change lanes. They only move in the constant direction in one way or another. So real quick, I'm going to win this game. I'm going to go right here, go up here, get past this quick one. Alright, and then we see that I won. And you can see it here. It says that I win. And that pauses the game state for a second. And then the game state is restarted. And then you can play again indefinitely. Right here is the number of lives in binary form. Right now it's 3. So I'm going to lose the game real quick, and see how that affects the state of the game. So I just lost 1 life. Now it's just 2 lives I have. Lost another life. Now I just have 1. Now it says I lose. You see that, right? And so the game state pauses again for a little while, and then it's going to reset again. And that's pretty much it. That's my Frogger game. I'll include multiple configurations of the game for your for different difficulties, different velocity configurations and settings. Maybe some more lives, but it's pretty simple. You can base your strategy on the speed of the cars and their positioning relative to you. I'll just also show off the boundary here. So that's a 9, but it can't go over that. If I go all the way down to 1, you see it won't go past 0. And if I try to go down, it won't go past it won't go past 0. It'll just get reset back to 0. So that's an example of the boundaries being used correctly. And that's it. I hope you enjoyed my demonstration, and thank you for watching.